So how high can we go counting by 4 before we get larger than 53? What'd you say? 52? Who says 52? So that means that I to the power of 53 is really I to the power of 52 times I. I to the power of 52 is 1. So all I have left is I, and I equals I. So I to the power of 1 is equal to I, so that would be your answer. Who had that for number 1? All right, number 2, completing the square. That's the tricky one, right? Because that's the one that is a new concept for most of you. So the first thing you should do is add the 9. Second thing you want to do is take that B value, cut it in half, and then square it. So what's half of negative 16 squared? 64. So I'm going to add 64 here and here. So the reason why we did that is because we need this side to be a perfect square. So that factors down to x minus 8 squared. And that's going to equal 73. Now we take the square root of both sides, which gives us x minus 8 equals plus or minus the square root of 73. So looking at those pink numbers that you see in the front, which are perfect squares, can I divide any of those perfect squares into 73? Can I divide it by 4, 9, 16, 25, or 36? Who says no? So because you can't, we just leave it alone. We can't do anything with that. So all I need to do is add this 8 over, which is going to give me x equals a positive 8 plus or minus the square root of 73. All right, so that is our bell work. Any questions? So now we're going to start Appendix 10. Appendix 10 is indexes. So this week we have a lot of homework due. I am so sorry, but if you shouldn't wait until it's due to start it. So for example, homework 3 should be done. Homework 4 is over Appendix 10, and that is due Thursday. So if you're titling your notes, Appendix 10 is called nth roots and rational exponents. So we're simplifying radicals, square roots, cube roots, fourth roots, etc. This is on Canvas, so you don't need to copy that down. I just took a little clip from Canvas. So this is our last appendix unit, and then we'll start chapter 1. So any questions? All right, so let's go ahead and get started. Now, you don't necessarily need to write this down, but it is important that you understand that anything written with a radical can also be written with an exponent that's a fraction. So, for example, you might want to write this down. The square root of 5 can be written as 5 to the power of 1/2. So whatever number is in the elbow, I like to call this the elbow, is also going to be the denominator of your fraction. Another example would be the cube root of 2. So how do you think I'm going to write that? 2 to the power of what? 1/3. Lastly, let's do one more. The fourth root of a cubed. All right, so now that's going to be a to the power of 4, but my exponent that's underneath, that goes in the numerator of my exponent. So that's just something to kind of keep in mind. So when you have your exponent, The denominator, we call that the root or the index. And the numerator is your power. And we will have time to focus on that again shortly. Yes? Are you talking about, oh, I didn't put it there. Thank you. You're like, what? You didn't put it there. Yeah, the 3 should be here. Was that your question? Yeah. So that would be a to the power of 3 over 4. Thank you. All right, so let's go ahead and get started. Take a moment and copy down these 3. And then we will talk about simplifying them. First couple are pretty straightforward. Square root of 49, cube root of 27, cube root of negative 8. So when you don't see a number in the elbow, that means it's 2. So for the first one, it's a square root. We don't put it when it's a 2. And that's the lowest you can go. There's no such thing as a first root. So what is the square root of 49? 7. Done. 27. So we have to figure out what number to the power of 3 is going to give you 27. And let me go back here. Let me go back to question 1. So I have the square root of, so we know that 7 squared is 49, which is why they just cancel and I'm left with a 7. So the cube root of 27 is the same as 3 to the power of 3. So if you take your calculator and you take 3 times 3 times 3, you get 27. So a root and a power cancel out, so your answer is just 3. All right, now let's talk about negatives. Let's go off to the side. If you have a negative 1 and in the elbow, it's an even number. This number is even. I don't care what it is. It could be a 2, 4, 6, 8. You cannot take the even index of a negative. So that negative 1 has to stay. Nothing can change. It's going to stay this whatever root of negative 1. However, if it's odd, so this number in the elbow is an odd number, it doesn't stay. It comes out and it becomes just negative 1. So that's something important to keep in mind when you come across negatives. If it's an even index, we just leave it. We don't change it. It just stays whatever root negative 1. It stays under the hood. If it's an odd index, we can take it out. So the reason why I wanted to talk about that is in number 3, notice how we have a negative. The first thing you want to do always is separate that. So I'm going to separate this to the cube root of negative 1 times the cube root of 8. You cannot leave a negative under a radical. So is this negative 1 going to come out or is it going to stay? Come out because 3 is odd. So this is just a negative 1. Does anybody know what the cube root of 8 is? 2. 2 times 2 times 2 is 8. So this is really negative 1 times 2, which means for number 3, my answer is just negative 2. Because you multiply those 2 answers together. So these are my 3 answers. Any questions? I know we're tired. Mondays are hard. Tuesdays are hard, and so are Wednesdays, Thursdays, and also Fridays. But, we'll get through it. All right, let's copy down 4, 5, and 6. So what number to the power of 4 is going to give you 16? 2. So 2 to the power of 4, because remember our index is 4, it's not 2. 2 times 2 times 2 times 2 is 16, which is why these can cancel, and my final answer is 2. All right, number 5 has a negative. So again, you start off by separating it. So I'm going to separate the -1 and the 16. So will this stay or will it come out? Who says stay? Yep, because 4 is even, so I can't do anything with that. It has to stay right there. And we already figured out that this is 2. So my answer will be written as 2 times the 4th root of -1. Because that -1 has to stay. We can't take it out. All right, now let's talk about variables. Now you don't have to do this, but I'm going to show it to you one time because it did help my 4th period. So when you have the 4th root of variables, if I have x to the 8th, that means I have 8 x's under here. 1, 2, 3, 4. Okay. That's what that means. That index is telling me how many to put in a group. So if I have an index of 4, I have 2 groups. Does everybody see that? Is there any x that's left out of a group? So because I have 2 groups, this equals x squared, and that would be my answer. So the 4th root of x to the power of 8 is x squared. All right, we're doing pretty good with time. Let's look at 7, 8, and 9. All right, let's go ahead and copy down 7, 8, and 9. We only got one more slide after this. I think yawning is contagious. Like when I yawn, you yawn, and then Robin will yawn, and then it just kind of goes.
I always yawn.
Me too. Tired. So we have different indexes. I have a 5th root, then I have a cube root, and I have a 4th root. So now we're looking at multiple things underneath the radical. So again, I'm not going to write out 10 y's, but if you want to, you can. But essentially what you're asking yourself, if you have 10 people and I want to put them in groups of 5, how many groups of 5 can I make with 10 people? 2. Who agrees that it's 2? Will there be anyone left out of a group? So that means that my final answer would just be y squared. All right, so now let's get down to the nitty gritty. So here, question number 8, there are 3 different things underneath my cube root. So you need to separate them and look at them separately. So I have the cube root of 125. And then I have the cube root of x to the power 6. And then I have the cube root of y to the power of 3. And it doesn't want to write. There we go. All right, so let's look at this first one. 125 is actually a perfect cube. 5 times 5 times 5 is 125. So this becomes a 5. That's what this gives you. If you have 6 people that you want to put in a group of 3, how many groups of 3 can you make with 6 people? 2. And then if I have 3 people, I can only make 1 group of 3. So my final answer is just 5x squared y. All right, go ahead and try to do number 9 on your own. Then I'll put up the answer shortly. All right, what would you put for number 9? Luke, can you say that one more time? Who got a cubed b squared? I would agree. If you have 12 people, you can make 3 groups of 4. Nobody's left out. If you have 8 people, you can make 2 groups of 4. Nobody's left out. All right, just a few more. Now for this one, I don't recommend you copy down the bottom row. As a matter of fact, I'm going to take that off temporarily. Let's look at 10 and 11. Success, are you okay? Yeah, okay. So now we have things being left out. So there are 3 things underneath my square root. I have the square root of a to the power of 10. Then I have the square root of just b. And then I have the square root of c to the power of 9. So what is my index for number 10? When you don't see an index, show me with your finger. What's the index? 2. So if I have 10 people, how many pairs can I make with 10 people? 5. So that would just be a to the 5th. If I only have 1 person, I don't have enough to make a pair, which is why that has to stay. So I'm just going to put that in the back. It has to stay. So I can't take out a pair with 1 person. If I have 9 people, show me with your fingers, how many pairs can you make with 9 people? You can make 4. So that would be c to the 4th. But there is 1 c that's left over that has to stay, and it's going to stay along with that b. So that would be your answer. All right, let's look at number 11. So again, we have a negative, so we got to look at that separately. So I have a -1, and then I have a 40, and then I have x to the 14th. And then I have y to the 10th. So we got to look at each one separately. So for this first one, does this come out or does it stay? Who says it comes out? Who says it stays? Who's not sure? So you want to look at this number. If that's an odd number, this 3, which is not working for me right now. I don't know why. Okay, this is odd, which means it's going to come out. So this just changes to a -1. Okay, I'm having all kind of problems with my little pen all of a sudden. Okay, that becomes that. It just comes out. Now, this is where it gets tricky. 40 is not a perfect cube. Okay, but 2 to the power of 3 is 8. And does 8 go into 40? Yes. So that means that I can break this apart to the cube root of 8 times the cube root of 5. So I just knew that. I knew that. So you might want to, you know how we have our perfect squares in the front of the room? You may want to kind of know a few of your perfect cubes. So like 2 to the power of 3 is 8. 3 to the power of 3 is 27. So if it's a cube root, you may want to just write out the first few. All right, so the cube root of 8 is 2. So this becomes a 2. This has to stay. All right, let's look at the 14. If I have 14 people, how many groups of 3 can I make with 14 people? Show me with your fingers. How many groups of 3 can you make with 14? Yep. So I have 4. So that means that this is going to become x to the 4th times the cube root of, now what's going to be left over? How many will be left over? 2. So this also has to stay. And we'll clean it all up at the end. And then lastly, if I have 10 people, how many groups can I make with 10 people? 3 groups. And who's left out? How many? 1. So this has to stay. All right, so now let's put it all together. So everything that comes out would be the -1 times 2, the x to the 4th, and the y cubed. So that means that my answer is going to be -2 x to the 4th, y to the 3rd, because all of that can come out. And then we're going to make our cube root. Under the cube root, I have a 5, a x squared, and a y. So that one I would say is pretty much the level of questioning that you're going to have to do on the test. Does anybody need more time copying down 11 before I clear it off? All right, last 2, go ahead and copy them down. 12 and 13. So you have to remember your exponent laws to do this one. When do you add them? When do you multiply them? When do you subtract them? So for number 12, what am I going to do with my exponents? Do I add them or subtract them or multiply them? Add them, because we know, I don't know if you remember, but if you have exponents and they're being multiplied, or if you have 2 terms. So for example, if I have x squared times x to the power of 5, that would give me x to the 7th. So that's going back to algebra 1. So for this one, we are just adding. And because we have a common denominator, we can add them. So this is what we have. 2/3 plus 5/3 is 7/3. So now let's go back to the definition that we learned at the very beginning. This is my power. This is my root. So what I have is the cube root of x to the 7th. So that needs to be simplified. How many groups of 3 can I make with 7 people? Show me with your fingers. How many groups of 3? So that means x squared can come out. But then there will be 1 that has to stay. That would be your final answer. All right, go ahead and add your exponents, and then we have to subtract for 13. So that would be B. So in the top, I can add them. So that would be 10 over 4 and 1 over 4. And then we subtract. So that would be B to the power of 9 over 4. So let's go ahead and write that. The fourth root of B, 9. Go ahead and see if you can simplify that. Show me with your fingers, how many groups can you make? If you have 9 people, how many groups of 4 can you make? You can make 2. And is there anybody left out? How many? 1. So that would be the fourth root of just B. And that would be your answer. Okay.